Okay, fine, great. So this is just to tell you that right now the particular content is being like streamed onto YouTube as well. People can watch but cannot ask questions to us. Okay, so let's begin. So today we are going to discuss about LVM, like logical volume management. For that, we would need EC2 machine where we are going to perform this practical. So just allow me to have a moment till the time machine is being created. So LVM is really necessary, especially in that particular case, if you are working with on-prem data center, because in cloud, usually we directly increase the volume size. LVMs are not used in cloud environment. But yes, if you want to go for it, then sure, you can do it. But yes, if you are working on cloud and versus on-prem, and on-prem is preferred to have LVM mechanism enabled for every individual machine created. Okay, let's give it a name like LVM, like Linux VM. Let's select RHL9. This is going to be RHL9 HVM. We are going to have like T2 micro machine, key pair. Let us create new key pair. Linux box. Mumbai. Since I'm going to use my Linux terminal, or you can call that like MacBook terminal, so I'm going to use .pem, not with .ppk. Let's create it. Okay, then we need to select here the networking information, what VPC I'm going to create in. So obviously this is going to my default VPC. If you want to have any preference while selecting any kind of availability zone, then definitely you can do that. I'm going to select, let us say 1A. You can go with anyone. Now, do you have any security group available or you want to create new? So in new security group, by default port number 22, which is used for SSH, will be open from anywhere. You can read the rule here. Like rule with source, this is allow all IP addresses to access your instance. We recommend setting security group rule should allow access only from non-IP address. Because I am going to create this machine only for testing purpose, so I have nothing to worry. But obviously, if you want to allow from specific, then you can select here custom and you can define your own CIDR block. Whatever, let us say your company IP address, your own VPN IP address, your ISP provided public IP address, you can whitelist here. So right now I'm going to define as anywhere like before. I'm going to add one default EBS with GP3 because we are going to perform practical of LVM. So I would need to have some more disk space associated with this particular VM. Since I don't want to add this again, so I would like to add this right away, right now, along with this particular one. So I'm going to have 20 GB disk associated with this instance. So 10 GB plus 20 GB additional. So guys, any questions so far? Or we are good?
Good, sir.
Okay, very good. Okay, so this instance is created. We can jump onto this instance. So this is a particular machine which is created. If you want to see the status of it, currently it is running. Status checks are being initialized. We will get to know whether instance is running properly or not. But yes, in the meanwhile, since the machine is up and running, we will try to log into this machine. We will hit on this particular. So there are multiple ways to connect. We can connect here with the help of EC2 connect. But for that, you will be allowed to connect via browser. In order to connect to this, you need to have some agent running onto that machine. Moreover, obviously I was knowing it because right now the particular instance does not allow you to access it because some additional profiles from AWS side should be associated there. That's why this error came. But yes, if you do some additional settings, you can do that. Right now, we are going to log into this particular machine with the help of SSH client. Okay, so this is the particular command which I can use as is, but obviously I need to ensure that my current working directory has to be the same where this particular key is placed. For example, if I talk about my keys are available here in downloads, Linux, box, Mumbai. This is my key. This is my key pair. Okay, I'll have to define it ls-l. My key is available here, and that is it. Okay. So now what next I want to do? I'll copy this particular command and I'll log into this machine. I'm here. Linux box is the particular name which I have given to this machine, sudo su hyphen, in order to escalate my privilege. Okay, guys, any questions so far, like what we are doing, why these steps are needed? Yes, guys, any questions?
No,
Guys,
sir.
any questions? Okay, good. So now if I need to check that how many disks are associated with this particular machine, then how do I check?
LSBLK.
Okay. LHBLK is the particular command which I can execute in order to check associated disk, or we can execute dmessage command. So it will tell me like XVDA is the particular block device which is found associated with this particular server. Or we can run a command fdisk -l. So this command will tell me like how many total disks are associated, like dev xvda and dev xvdb. These two disks are associated with this. But as you see, this particular disk does not have any partition information available. Okay, fine. Now, let us log into this particular disk. Let us try to access that specific disk and see like what does it say. So it will be done with the help of fdisk/dev xvdb. So this is the particular file which we have. Okay. So right now we are going to print here like help menu, that what we can do. You can check, you can see like generic commands are delete partition, list free, unpartitioned space available, list of non-partition type, addition new partition, print partition table. So these are the particular operation which we can do. So right now I'm going to create a new one. So I'll press here N for new partition. Now, as we discussed within last session as well, there are two different type of partitions which we can create initially, like it is primary partition or it is extended partition. So if you talk about initial days, so when we used to have Windows as well as Linux available on the same laptop, so that used to be called as dual boot operating system. So in that particular case, whether it is Linux operating system or it is Windows operating system, both the operating system used to require to have primary partitions. So in this particular case, right now we can create primary as well as extended partitions. So what we are going to do, we will create primary first. Partition number we are going to give as 1, or if we do not define, so it will select 1 automatically. Default cylinder, leave it like this. Now the very first partition we are going to create of 4 GB. So what kind of values are allowed to be given while creating partition? So it could be like KB, MB, GB, TB, and PB. So these type of values are allowed, and keep this thing in mind, plus then the particular size and the particular like these parameters like GB, MB, TB, PB, whatever. So now if you define a P for print the partition information, it will say that currently this particular partition is available XVDB1. It starts from here and here. The size is 4 GB and ID is 83. What is this ID means? Partition type. So if you see here print L, so it will tell you all the available partition type. Like what kind of partition you can create. So right now, if you see here, it is written like 83 is equal to Linux. If you want to create Linux swap, so you will have to define here 82. For example, if you want to create some other kind of like, if you want to create any partition which is going to be utilized under LVM, so you can define here 8E. So different type of partition information you can print using this. Right, okay. Moreover, like different aliases are available, 82, extended, UEFI. So different kind of information is available here as well. Okay, let us print the partition table. Let us create one more new. This time we are going to create, let us say, partition number 2. We are going to create primary partition number 2. Size we are going to give, let us say 8 GB. Okay, this is your talk about cylinder. Now, plus 8G. 8 GB partition we are going to create. So that is done. Now, if I want to see that how much free space is available in the particular disk where I'm working, so it is saying 8 GB. Let us create one more partition here. Let us create primary only. And we are going to define here all the default values. Like complete space is allocated, no free space available. And how do we check? Define capital F and you will get to know no free space left on this particular, only 6 MB is left. Fine. So now, if I want to write and quit this particular like information which I have done just now, I can press W. It means save and quit out of this particular table. Any question so far?
No, sir.
Okay. Any other one who has any question?
No, right now.
Okay, great. Good. Then we are good to go. So once again, we are going to run the same commands which we executed before in order to see the differences between initial stage and then the particular stage where we are right now and the particular upcoming steps, whatever we are going to do. So first of all, let us see lsblk command. This command was executed as the very first command in order to identify that how many disks are associated and whether any partitions are created. So earlier, only this particular information was available, not this one, because this particular disk like XVDB, this did not have any kind of partition cable available along with this. But right now, if you see, so these are available and these are going to be utilized for creating LVM. Okay, now one more thing I want to ask. Let us say if I want to know whether these partitions are formatted or not. How do we check that?
BLK ID.
Very good. BLK ID is the particular command like using which we can easily identify whether a partition is formatted or not. Wherever the partition is formatted, that will come under this particular. Like there will be type XFS or type ext4 or type XYZ. That sort of information would definitely come in. If that sort of information is not coming in, then, and one more thing is here, like either it will say part UUID, like partition UUID. UUID stands for Universal Unique Identifier. So it will be related to a partition, right? Or it will be related to a particular file system. So if it is file system, then it will be, this part UUID will be replaced by this UUID, right? Okay, let's move ahead. Now we need to check whether any LVM is available or not. So LVS command is not available. So we need to install it. DNF DNF install LVM. So all the packages which are related to LVM, so it means PV create, VG create, LV create, PV list, VG list, LV list. So that sort of commands we are going to install, because this particular operating system does not involve or does not include LVM as base package.
Sir,
That is,
what is the
yeah.
sir, what is the difference between LVM or LVM2 when I install LVM2?
Okay. So LVM2 is a latest type of LVM which ensures to create backup for every individual change whenever we are going to make any change in our operating system. So LVM2 is the base package as of today. This is a particular package, LVM2.
Okay, sir.
Okay. So now what we are going to do here, we are going to create one LVM, one PV. So what is PVS? Physical volume show. No volume available. No volume available here. And when we are talking about like what is to be done, okay. So in this particular case, we are going to create PV. So now what is this PV create? Let's dab. We have done this. Okay, guys, can any one of you tell me like what have we done right now?
We created physical volume.
And what is the physical volume?
Sir, this is like a uh, like a specific disk partition.
Okay, any other one? Okay, let me explain a little about it before creation of this particular one. Okay, let us say we have a particular disk. So right now, there are three different mount points. Let us say this is slash data. Let me increase size of this particular one to, let us say, 18. We have slash data, and the particular size of this data is, let us call it like 4 GB. We have one more mount point. Let us say we have here slash images. And size of this is, let us say, 8 GB. Now, let us say we have one more mount point here. Let us say we have here DB, or let us say backup. So these are the particular mount points which we have right now. Now there is a situation that we want to increase size of this disk. So for example, if there is a disk associated with this particular mount point, and that is of 4 GB only, we cannot increase the particular size of this disk. But if these are created on the top of LVM, so what does LVM do? Now, let us see that what is the advantage of creating LVM and these mount point on LVM. So right now, we do not directly create any partition or any mount point on the disk itself. What do we do? Let us say we have a particular disk. For example, the particular disk which is associated here, like this particular disk having size of 20 GB. What we are going to do? We are going to have this disk, let us say slash dev slash xvdb. This is a particular disk of, let us say, 20 GB, right? So we are not going to utilize this particular disk as whole. what we are going to do? We are going to declare it as PV, like physical volume. Physical volume is a logical unit. We are going to create this particular define. We are going to define this particular disk as physical volume. This will be
Yes, sir.
not physical volume. In the backend, only this disk is going to be utilized. But in order to create these mount points, what we are going to do? We are going to declare, we are going to put a logical layer on the top of this particular one. Now we have one disk. So the second step will be to create volume group. Now what does that mean, volume group? So for now we have this particular disk. We declare that particular disk as physical volume, and that physical volume is now a part of this volume group. So this particular disk, like this one, XVDB, so this particular disk has been associated under this particular volume group. Now, whenever we are going to create these mount points, so let us say these mount points will be created under this particular one. Like within this particular volume group, this mount point will be created. So now let us say that we have three. Okay. So guys, please do ask if you have any question that why we are doing this. Why I'm drawing this particular one, just to make you understand that how do things work? Why, what is the need of it? So guys, if you see, we have a disk of 20 GB. We created these three mount points like slash data, slash images, slash backup, and this 20 GB of partition is completely utilized. Now, if I need to increase the particular size of this slash data, maybe slash 4 to slash 8 or slash this image is slash 8 to 16 or maybe 10 GB, whatever. So I need some additional disk space. But if I would have created this particular data onto the raw disk, then this would have become a problem for me. But right now, since when we are talking about like this particular disk is not directly associated, but these are created on the top of logical volume. So individual partitions like this one, and this one, these are going to be created under volume, like volume group. I must call it not volume. This is known as volume group. So this volume group is going to be like logical container for all the physical volumes which we are going to have. And if someone is going to ask you what is the capacity of this particular volume group, so it can contain 255 physical volumes. It can be utilized as a container for 255 physical volumes. If we are working with LVM type 2, like this was a question from someone within the group. So these are going to be kind of logical container for up to 255 physical volumes. Okay. So guys, if you see, like we have already done this. Now, for example, if I want to increase size, so I will add another disk. Let us do one thing. Let us create these three first onto the particular terminal where we were supposed to be. So first of all, what we have done, previous, I have declared one partition like this one as PV, like physical volume. The same thing I'm going to do with rest of two, XVDB2, and the same thing I'm going to do with XVDB3. So right now, all the three volumes have been added or have been declared as physical volumes. If I want to run in detail, if I want to see the details of this one, I can run a command PV display. This will inform us in detail, like what is the PV name, what is the VG name, like has this particular physical volume be associated with any volume group? What is size of physical volume? Like, is it allocatable? What does that mean? Can we create some logical partition or some LVM out of this? So it is saying no. PE size not defined yet. Total PE not defined yet. free PE, allocated PE, not defined yet. When these are going to be defined, once these will become part of some volume group, only after that we shall be in a position to identify or to calculate the size of these physical volumes. Okay, so let us jump onto that quickly. VG create, let us give it a name, like let us say my wall, like my volume. And what are the particular disk going to be part of this volume, like slash dev xvdb, and in curly braces we can define 1 dot dot 3, like from 1 to 3 all the particular volumes I'm going to okay, that option was invalid. That comes along with lv create command, not here. So what I have done, all the three partitions I have attached or I have associated with this particular volume group with the name of my wall, like my volume group. Okay, so if I run the same command again, like PV display, so guys, what are we going to see? What kind of difference are we going to see? So we are going to see the very first difference, that the particular values which were in those form, like if you see the difference here, like it was saying no, 0, 0, 0, 0, and rest of things were not visible. So right now what we are going to see here, and we are going to see here like the very first thing, like wall size, allocatable years, PE size 4 MB, total free PE this many, total PE these many. So these sort of information are available. Okay, one more thing it is saying, like, is any amount of data allocated out of this particular physical volume? It says 0 MB. No, right? So that way. Now we can run command VGS. So it will tell us like what is the overall size of this volume group, what is utilized size, what is free, how many PVs are part of this volume group, how many LVMs are created, right? So these are the attributes. Moreover, the same command I can run here, VG display. So it will tell me the details of this volume group, like what is the name, what is format, like LVM1 or LVM2. So it says LVM2, metadata 3, like 3 areas are here. Metadata sequence number 1, like current physical volumes, active physical volumes, volume like VG size. VG means volume group size. About this physical volume, how many total PEs are there? How many free PEs? PE means physical extent. So extent is a unit, equal to 1 extent equal to 4 MB here. If you see size, PE size, physical extent size equal to 4 MB. So in order to calculate this 20 GB data, we need to divide it by 4, and that will become the extent size. Okay. Now let us
Sir,
create, yeah,
sir, I have a question. Sir, if we do multiply PE,
into,
uh,
into 4, then you will get the data into GB.
okay,
Because if you see here, 1 PE is equal to 4 MB.
okay,
So if you do this like this into 4, that will become equal to 20 GB of data.
yes, sir. That was my question.
Okay, fine, great. So now we are going to create LVM. LV create hyphen N. Now I'm going to create one LVM here. Let me give it a name. Let us say my LV, my LVM. I'm going to give it a particular size. So guys, there are 3 ways to define size to an LVM. What are these? Like first of all, I can define a capital L. Then I can define, let us say 19 GB. So if I define here capital L, like caps L, if I define, I will define the size in this particular way, right? Okay. If I define it like hyphen size, then I can define here the size like, let us say once again, like 19 GB. Or the third way to define the size here is L. So guys, if you remember that we were saying something like these many, like extent. So if I go here and I try to utilize these extent values, for example, I know that I want to utilize all the particular data available along with this particular. So what I need to do? Plus calculate the size, copy paste, where from? My wall. My volume, logical volume, my LVM created. And what is the particular size I have defined here? So either I could have defined 19.9 GB here, I could have defined hyphen and for size and then that particular one, or I could have defined a 19 GB, 19.9 GB, I could have defined that. So in order to create this particular album, what I have done here is I have utilized this particular small L option, which means I am going to allocate these many physical extent to this particular logical volume which I have created. Are we clear with that?
Yes, sir.
Okay, now let's run the command LVS. Like if any LVM is created, then PVS, yes, then VGS, yes. So right now, if you see three physical volumes were there, out of those physical volumes, we have created only one LVM. There is no free data available in volume group, and the total allocated size is 19.99 GB. Now, what we are going to do? We are going to create a particular mount point. Rather than creating three LVM, what I have done here is I have created only one. mkdir/data mkfs dot, let us say, xfs / dev. What is the LVM name? In order to identify LVM complete name, we can run a command lv display command. So this is the complete path of that LVM which we have just created. So we are going to format that LVM. In order to put some data onto that, we are going to run a command mkdir, okay, mkfs. Make file system dot xfs is the file system type which we intend to create. Then we are going to have like this. We are going to define the complete path of that LVM created. Okay, now how do we identify whether the file system which we wanted to create that has been created? So the same way, blkid command we are going to execute. So if you see here, just read this particular line. Dev mapper my wall dash my LVM. This is the particular name of that LVM which has been formatted with XFS file system type. Right, guys? So now what we are going to do? Let us copy this particular section and let's go to FS tab. Vim is not there, so let us go with VI, etc, FS tab, paste it. Now where we want it to mount it, / data. What is the file system type? XFS, then the particular permission, defaults, and then we are going to run here 0 and 0. That's it. Run a command mount-a. So as you can see, this particular LVM is mounted onto /data. Now the question here is, which I have and which I wanted to show you guys quickly, that right now we do not have any disk available in order to increase the size of this particular one. So for example, someone has created a file of 19 GB inside /data. So let us create a file. Data file I'm going to create. So guys, if you see, right now 97% of data has been utilized out of 20 GB. Right now, how much space is left? 774 MB space is left. So right now, my requirement here is I want to increase the size from 20 to, let us say, 30 GB. So what to do now?
Sir, we have to add a PV and After PV,
You do not have any
we
additional disk available.
don't have any disk additional.
Okay, so now
Sir,
we are going to add another disk along with this particular VM with the name of XVDC, and let us see. So we are here. We will go to instances. And we need to see the particular availability zone, that is AP South 1A for sure, because we intended to select that one. We will go to volume. Now create a volume. Let us define the size as only 10 GB. We need to ensure that we are going to create this volume under AP South 1A only. Create it. So we need to wait for some time till the time this volume comes in available state. Yes, it is available. We can utilize it right away. Otherwise, if we are going to create some size, maybe let us say 100 GB or 200 GB, so that may take a couple of seconds. So till that time, you will not be able to attach this volume to with any machine. Select the instance. Yes, that is running. See the name SDC. So this name may change after being allocated, after being associated with a particular disk to this particular server. Let us run a command, message. So if you see, this is coming with XVDC, not SDC, XVDC. Okay, one more thing I want to do here quickly. What? PV create, rather than creating additional partitions here, I'm just going to allocate that disk, XVDC. And now I'm going to extend the volume group like VG. If I run a command VGS volume group show, so there is only one volume group. So right now, what command should I run? Not VG create, VG extend. What is the volume group name? My wall. And what kind of disk I'm going to associate here? This one, XVDC. Extended successfully.
Yes, sir.
VG display. So right now, if you see earlier, there were only like 3 metadata areas. Right now we have 4. If you see overall size, earlier it was 19.9 GB, now it is 29.98. If you see total allocated P's are here, utilized are these many, and free are these. So I hope that we are clear with this. So right now, if we want to increase the size of this particular disk, okay, 20 GB to let us say 25 or whatever amount of size we want to increase, we can easily do that. And how are we going to do that? So in order to perform that activity, we will run a command LV extend. What is the name of that LVM? My wall, my LVM.
Sir, we can use hyper R, hyphen R.
Why to use hyphen R? So right now what I have done here is LV extend is the particular command, hyphen name which LVM I want to modify, and what is the particular size I want to increase. So right, if you see the particular message which is coming from here, size of logical volume, my wall slash my volume changed from 19.99 GB to 24.99 GB. That was I wanted to do. Okay, good. Now what next we are going to do, guys? It is still the same. So right now I need to run a command here because the particular size of LVM that has been increased to 24 GB, but the particular file system which we created on this particular LVM, that has yet not been extended. So right now what we need to do here is we need to extend the file system size. So the command here is xfs underscore growfs and the LVM name. Now run the same command again. dev-th 25 GB. Are we clear with that? Like, how do we extend LVM? We are not supposed to reduce LVM. Why it is so? Because it may end up corrupting the data. So are we clear with that, guys?
Yes, sir.
Fine. So anything else you would like to know in LVM?
Sir, what is mapper?
It holds your logical mapping of your disk. Like the particular linking of those devices which are created are mapped under this particular device in this particular folder known as mapper. So for example, if you create another LVM, so like logical linking of that particular LVM will come under this particular folder once again. So either you can define, let us say, /dev my wall LVM. Then this is the same thing.
Yes,
This
sir.
is also soft link to this particular /dm0, right? Disk mapper 0. Or you can go with this particular link, ll/dev mapper my wall and my LVM. So end of the day, whether you define it like this or you define like this, so end of the day, both the particular logical link, like the soft links, are pointing to same device, same disk mapper. Are we clear with that?
Yes, sir.
So these are just two different ways to reach out to your LVM or to point to your LVM. Clear, guys? Okay, fine. Then, okay, then I have that we are good for today. And what are we going to discuss tomorrow?
Sir, I have a question.
Please
Sir,
go ahead.
when I removed LVM, so how can recover?
Okay, that is also good. So how to recover LVM? So for example, there is an LVM. First of all, unmount it. Run a command lv remove dev my wall and this one. Now it is going to say, do you really want to remove active logical volume my wall / my LVM? I'll say yes, I want to remove it. LVM removed successfully. No LVM available. But if I want to check etc LVM now archive, these are the particular files which are available in the form of backup, right?
Yes, sir.
But if I open any of these files, for example, I'm going to open this one. So this is going to print such kind of information. Obviously, that is not going to be very, very useful for me in this particular form at least, right? So what to do in such case? So in this particular case, we are going to run a command vgcfg restore -l, and what is the particular
Hyphen list.
okay, so that was vgcfg restore hyphen, okay, let me show you the command once again, -l for list. Then we need to define here our volume group name. If we are not going to define the volume group name, then definitely it will not help or it will not print the required information. So if you go through this particular command, So if you see this particular is etc LVM archive my wall. This is the particular file name created before executing LV remove command. So this is the final backup which was taken before removing this particular LVM. So what we need to do here is I'll go back like VG restore -f file. Then after this one,
My VG.
my wall. I'm sorry. I once again missed to define the particular volume group name. So what is the command here? VG restore -f. -f stands for file. Like what is the particular archive file which we have? This is the file we have. Where from? This particular volume. Now can we run the command LVS? Yes, that is available. But if you see here, LV status is not available. And why is that not available? Because we removed that and we have yet not activated it. So how to do it? LV change -ay dev this is the command LV change -ay dev my wall my LVM. So what does it say? LV status available, and initially and earlier it was showing not available. Once again, if we run the command mount -a df-th. So yes, we are able to see the particular data and the particular LVM once again the same state where we were before. So are we clear with that?
Yes, sir. Sir, I did same type of exercise, but I don't know why my LVM did not restore.
So Teja is asking here, like, sir, if we are in cloud, then also can we perform this type of operations? So Teja, just for information, yes, we can do that. So the particular machine which we are utilizing here is created in cloud only, but that will be depending upon the use case. But these are basic and the very required kind of activities which are supposed to be performed by every individual one. Are we clear with that? And guys, please make sure once you are done with this kind of practical, so you need to ensure that you are going to remove your machines which you have created in order to perform this practical, because beyond 30 GB disk utilization are paid. So obviously we are not going to have unwanted data available in our account. So I'm also going to do the same. umount/data and I'm going to terminate the instance as well. Terminate the machine. It is showing that some additional volumes are available. So once this machine is terminated, after that, we are going to remove the volumes once this machine is terminated. Otherwise, we will have to unmount, like deassociate the particular volume, detach the volume, then after we shall be deleting it. But once this machine is terminated, then we can quickly go and remove those particular volumes. So I hope that we are going to discuss file permission kind of things tomorrow, right?
Yes, sir.
Or maybe before that, we can go for user management, because unless user management is clear, it will not be very good idea to go for file permissions. So let us go for user management tomorrow, then we can go for file permission. First of all, user management, then file permission. So fine, guys. Thank you very much. So that is it for today.
Sir,
And
what is the purpose of format any disk?
format means we are going to create file system on any disk, and file system allows us to store the data onto the particular server.
Okay.
Okay, then take care. See you tomorrow. Till then, bye bye. Take care.
Thank you so much, sir.
Thank you.
Okay, take care.
Sir, basic classes complete.
Maybe we can continue with basic if you guys want. Okay, let us discuss.